Hi, so I just wanted to demonstrate a program I made. It's a projectile motion calculator, and you can take into account air drag. And if you find it useful in the video and you'd like it, there's a link in the description. You can download it for free. So it's pretty much the first program I made, so if you find errors in it, please report them to me just so I learn what to do better next time. Anyway, so basically it's a real-time graphing simulator. You can see right there. It actually runs very smoothly, but my video capture is quite choppy. So you can change the normal things like, say, initial speed. Now it's running a little faster, it's zoomed out, so you might not notice that it went further, but it did. And you can change, like, again, another thing is, say, launch angle. You can launch it 90 degrees, a little ridiculous, but launch at 70 degrees. And you can see it there, launch at 70 degrees, just as you'd expect. You can launch at a certain height. Say you launch at 100 meters. You can launch it at even an angle of 0 if you'd like. And you can see, there you go. Some of the other things, of course, you can change air density, drag coefficient, cross-sectional area, and so on. I'm not going to really play with those because you can do those yourself if you'd like. And if you only want to see the ideal path, you can uncheck display ideal path, and there's just your air resistance path. And if you also don't want to wait for everything to stop, you can manually uncheck run in real time, and it'll just give you a graph right away without having to wait for it. Over here you'll have some statistics for each flight, and as far as accuracy goes, I know that the ideal path is very accurate because I tested it against online calculators, but the air resistance path I cannot guarantee because there didn't seem to be any calculators that I found online that would give you the actual distance, and mathematically there doesn't seem to be an easy way, at least, to work it out. So I used very, very small units of time to do so, and I think it's a reasonable approximation, but I cannot guarantee it. I think, though, that it's pretty good. And as far as bugs go, a couple known bugs is if you enter a really, really low speed, you can sometimes get the program to not recognize that the projectile already hit the ground, and that's under very low speeds, like a meter per second or something. And so sometimes you just have to manually press stop simulation, so it's not a big deal. And the other issue is if you enter really, really strange values, like an initial speed of 1,000 and a drag coefficient of 500, I don't think you're even allowed to do that, but even if you do, what'll happen is the acceleration might even be so much that in the unit of time that I use, the tiny unit of time, it can just screw up the simulation. You'll get very, very funky looking graphs. Sometimes it'll actually go backwards, which of course is impossible. But if you enter normal values, and normal goes up pretty high, like up to 800 meters per second, 1,000 meters per second, and reasonable drag coefficients, you'll get reasonable looking graphs. So it's pretty good overall. Anyway, links in the description if you'd want it. Again, find any problems, you like it, you don't like it, go ahead and tell me in the video. It's my first program, so I'd really be happy if someone gave me suggestions. So thank you.